Hi everyone. Today we're going to be looking at transformations of functions of parent functions. So here we're going to get some practice. I want to match these graphs here below with the parent function that it's represented and then list the transformations. Okay, so for this first one here, the parent function, this is a square root function. So y is equal to the square root of x. The transformations, this is oriented the correct way, or at least the same as the parent function, and it's shifted to the right 2 units and then up 3 units. Okay, so our transformations, we have a horizontal shift, right 2 units, and then we have a vertical shift, up 3 units. Okay. For number 2, our parent function, this is a parabola. We've got that U-shaped graph. It's opening downward, and it's shifted to the right 2 units. So here we have our parent function is a quadratic, y equals x squared. The transformations, well, the first transformation is to the input. We're horizontally shifting to the right 2 units. And then we've got that flip. It's reflected over the x-axis. So reflection over the x-axis. Okay. Number 3, here we've got a V-shaped graph. This is the absolute value function. So the parent function is y is equal to the absolute value of x. The transformations here, well, this one, each line has a slope of 1 or -1. So there's no vertical or horizontal stretches or compressions. We are shifting to the left 2 units, and we're shifting down 1 unit. So the transformations, first is a horizontal shift to the left 2 units, and then a vertical shift down 1 unit. Okay. The next one, here we've got like an S-shaped graph. This is the cube root function. So this is y equals the cube root of x, where the transformations, there's only one, and that's the horizontal shift to the right 2 units. Okay. Go ahead and flip the page. Number 5, this one looks similar to number 1, but now it's flipped. So here we have, again, the square root function. So the parent function is y is equal to the square root of x. And then our transformations, the first thing that we have is the horizontal shift to the right 2 units. And then we have a reflection over the y-axis. Okay. Number 6, we've got that V-shaped graph again. This is the absolute value function. So y is equal to the absolute value of x. We're shifting up 4 units, and then we're also reflecting. It's opening down, so this is a reflection over the x-axis. So we'll start with that, a reflection over the x-axis, and then a vertical shift up 4 units. Okay. Number 7, here we have that U-shaped graph. So this is the quadratic function, so y equals x squared. And we have a reflection. It's flipped. So reflection over the x-axis. And then it's shifted down 2 units. So a vertical shift down 2 units. And last one, we've got another square root function, y equals square root of x. And this is, we're shifting to the left 2 units, and then we're reflecting over the x-axis. So this is a horizontal shift. Left 2 units. And then there's also a reflection over the x-axis. Okay. Our last example here, go ahead and take out your Inspire and graph both of these equations, these functions, f of x and g of x. X squared minus 2x minus 3. So if I wanted to look at this here is our f of x, x squared minus 2x minus 3. And then g of x is equal to the absolute value of the same expression. So I put that here. To get that absolute value, by the way, you can hit this key just to the left of like this book. And that's your functions. So we'll stack both of those on top of one another. So you might notice some similarities. So here is f of x and here is g of x. So some similarities, they're exactly the same for like these parts right here. From like negative infinity to negative 1, and then from like 3 to infinity. However, this middle part between negative 1 and 3 is different. For the quadratic, down here, it is below the x-axis. For the absolute value, it's above the x-axis. Otherwise, it's identical. It's an exact reflection. So how are they similar? These graphs, these functions are exactly the same. So over those intervals. So they are exactly the same over the interval negative infinity to negative 1, and including, because that's an x-intercept, and then also from 3 to infinity. They're different in between. So over the interval negative 1 to 3, and we don't want to include this, g of x is f of x reflected over the x-axis. So why did the absolute value change the graph of f of x? Well, we know that for f of x, all of those negative values, these are all underneath the x-axis, so all of these f of x values are negative, those outputs. The absolute value takes all of those function outputs and returns the positive value, right? So all of these, which would be negative, then it flips it and becomes positive. And so the graph kind of bounces off the x-axis. And then those quantities are still the same, but now the positive values. Okay, so for that interval, negative 1 to 3, we return all of the positive outputs of f of x. Okay, so we can say that for any negative f of x values, and just as a reminder, those are function outputs, the absolute value causes the same positive g of x values. And again, those are outputs. Okay, so for any negative f of x values, the absolute value causes the same positive g of x values. Okay. All right, so in summary, here are some graphs of parent functions, some transformed parent functions. The goal by the end of this unit is that you can take a look at a graph and come up with the equation for that function, or maybe given the function, you could graph it without the aid of without a graphing aid like a graphing calculator. All right, so we're going to get a lot of practice on this. We'll see you tomorrow in class. Have a great day, everybody. Goodbye.